Welcome to our course Data Binding in Xamarin.Forms. My name is Rene. In this course today, we'll have a look at the data binding features of Xamarin.Forms. We will learn how we can use this feature to our advantage in order to decouple our code from the UI. Let's start by looking at what data binding is capable of. Looking at any app out there, they always have some sort of model, some sort of data, and we, as the developer, we are responsible to visualize this data. Data can either be something that is internal to the application, or it can be something that is external. Maybe you download information from a web service, or you read it from a database. Data can be complex. It can be, for instance, a class that contains information about a person, like first name, last name, age. Or it can be something very trivial, like a string. That's also a model. But whatever it is, we have to get this data into something that can be consumed by our end users. And the classic approach to achieve this is shown here. In our code behind in Xamarin.Forms, we would just take the information from our model and assign it to properties that are exposed by the UI elements that we are using. By doing that, we move data from our model into the UI. Now, of course, many UI elements, they are interactive. So users can switch checkboxes, they can enter text, they can press buttons. In order to react to this, we would be using events. You can see an example here, how we use the name.textChanged event in order to update our model. This allows us to move data back from the UI into our model. Now, as I've already mentioned, there is nothing really wrong with this approach. I mean, it's working. However, with regards to maintainability and testing our app, code that we have just seen on the previous slide can cause issues. The main problem here is that you literally clutter your code behind with UI relevant parts. And the more UI elements you have, the harder it will be to spot what your actual logic is. And it's really almost impossible to automatically test such code. I mean, you could run an automated UI test, but any test will always require you to run the application on a specific device, or on the simulator, or on an emulator. The reason for all of this is that our UI, in this case, in the classic approach, is very, very tightly coupled to the code behind. So whenever you change either side, it will affect the other. And this is where data binding can help. Let's analyze what data binding is. Well, data binding, or the binding object, is represented by the blue circle here in the center of the screen. What you see here is really just a class. There is a binding object in Xamarin.Forms, and the job of this object is to look at some source, and that source can be any object. And any object, that means, well, that's our model. So data binding works with anything that you already have in your code. The binding class, it looks at that object and it relies on public properties in your source object. So that's a requirement here. It does not work with fields. It does not work with private properties. No, you must expose public properties there. The binding object then goes ahead and says, okay, I know what my source object is. Now, where should I take this data to? So besides the source, our binding object also wants to know about a target. And then it's going to move data from the source into the target. If you look at the target here on the right-hand side, you'll notice that the target, it cannot be any object. Here are certain requirements. A target must always be a bindable object, and it must expose bindable properties. Now, you don't have to worry too much about this for now, because pretty much all of the UI elements that we have in Xamarin.Forms, they are bindable objects and they expose bindable properties. We'll see that in a bit. Also notice how the binding object here has arrows going into both directions. So not only is it capable of moving data from the source to the target, it can also transport data back, which means if the user enters something into an entry field, it will update our model. Let's zoom in a bit. In order to create a binding, we will always need three pieces of information. We have already discussed them. Source, well, that's where our data is coming from. Any accessible object will work here, as long as it has got public properties. The next bit that we haven't talked about, that's the path. Think about a source object that is a bit more complex. Think about a person object. Your person object, it likely has a public property for the first name, another public property for the last name, for the age, etc. So the moment you create a binding, you tell it that the source, well, that's the person object. But then you want to transport data, let's say, to a UI label. Well, which part of the source should it take? And that's exactly what the path specifies. So the path is a string that represents a public property in your source. So you would tell it from my source object, which is a person object, take the first name property and move it into the target. That brings us to the target. We have to tell it, well, here's the UI element that we want to data bind to. That UI element has got specific properties. A label, for instance, has got a text property. So we would tell it, take our first name public property of the source object and move it into the text property of our target. Let's go ahead and create such a binding. Remember, binding is just a type. We create an instance of it, and we can do this in code. Maybe you have already heard about bindings and you thought that bindings are something that only exist in XAML. Well, that's not true. You can create bindings dynamically, and we can do it in code as seen here. Let's start at the very top. We first have our model object here. In this case, it's a task. This task has got many properties. One of them is shown here. It's the title property. Up next, we have our UI element. Here in this case, it's an entry field. We then create our binding. And we tell the binding, number one, where to get its data from. The first ingredient, that's our source. And we just point the source to our task object. Next thing we need is the path. Now that we have identified the source, we must make sure that we tell our binding which part of the source is it that we want to transport over. And here we say the path equals the string title. And notice how the string title matches the name of the public property of our to-do object. There are different ways to specify the path. What you have just seen is the property name itself. The binding engine in Xamarin.Forms also allows you to access sub-objects. So you would just separate these via dot. Or you can use indexes, either via name or via numeric value. Finally, you can also identify the object itself. So let's say the object that you want to move from your source into the target is just a string. Now your source would be that string object, but you don't want to transport a property of that string into the UI. No, you want to transport the string itself. So you would specify a binding or a path that just uses a dot, the object itself. The last ingredient that we need here, well, that's our target. And here you can see why it is necessary that our target is a bindable object, because it has to expose specific methods. Here in this case, name is our UI element. It's an entry field. It is a bindable object, and as such, it offers us the setBinding method. The first parameter of this method, that's the bindable property that we want to use to move our data into. In this case, it's the entry's text property. So this tells us data will go from our source object, which is the to-do object. It will use the title property and move the information of the title property into our entry field and assign it to the text property. The last bit that is missing here, besides the text property, which we specify as the first parameter, is our binding. With that, we have set everything up, and data will flow now from our model into the UI, and if our users enter something, back into the model. Now I hear you. If you look at this and you compare it to the original version that we had, the classic approach, where we manually moved data and we wired up the event handlers, well, what exactly have we won? We have replaced like 10 lines of code with 10 lines of different code. Well, and I agree, using data bindings in code is not very common. But data binding really shines the moment you start using XAML. So let's have a look at that. Here we have the same UI represented in a XAML file. And we can identify exactly the same three ingredients in that file. So that would be source, path, and target. Let's see if we can find them. The source is specified here. Notice how it is an attribute of the binding object. We use this binding object or this binding extension by opening the curly brace, then writing binding, and providing the source information. In this example here, our source is a static resource, which we put into the resource dictionary. You can really use any source. Remember, the source can be any object. You could use the x:static extension, and we'll get to more examples later. The second bit that we need, well, that's our path, and here we have it. It says binding title. Title identifies the property in our object. If you wonder now, well, I have to specify source equals, but not path equals. Why that? Well, the first argument that you pass to the binding extension here, that is always interpreted as the path argument. So you can write path equals, but you can also omit that. Finally, we need to find our target. And in XAML, there's no specific property if you use bindings. You would use exactly the same attribute or the same property that is also used if you assign a string. So here we just say we want to set or we want to use that binding for the text attribute of our entry field. Now let's dive a bit deeper. I just used a person object as an example. And we said that our person object likely has first name, last name, age, and many other properties in there. Here in this case, we have a to-do object. And notice how also our to-do object, it has got multiple properties: title, notes, completed. If you are given the task to create a UI to visualize this to-do object, well, you very likely would create an entry field for title, an entry field for the notes, a switch for the completed Boolean. And all these three properties, they have something in common. They are all from the same model, and they're all on the same page in your UI. Now, instead of repeating the source over and over again, which would be the same, it would always be the very same to-do object, we can set up a default binding source. And that default binding source is defined by setting the binding context. So let's have a look at that. We start in code. This example is similar to what we have seen before when we introduced bindings first. Again, we have a to-do object. We're using a slightly different API to create the binding. But the important bit here is that instead of setting a source on the binding object, we set the binding context for our UI element. And again, notice how this makes it clear why our target object needs to be a special type of object, a bindable object. Because it not only has these set binding methods, it also has this binding context property. What we do here is we tell our UI element, whenever somebody is using a binding, you should use the task object as the source unless we specify another source explicitly. So if we create the binding in the next line, notice how we can completely omit the source. And again, the question is now, of course, we have replaced the repetitive assignment of source and instead now have a repetitive assignment of binding context. How does that help us? There's a thing about binding context which I haven't told you yet. That is that binding context will be inherited from parent to child elements in your UI hierarchy. Which means if you are using any UI element and you have a binding assigned to it, and you do not specify a source explicitly, it will walk up the UI hierarchy until it finds a binding context. This means that we can put the binding context onto our page. So here in this example, we just assign our source object, our to-do object, to the binding context property of the page. And that means if we now create bindings, we no longer have to provide the binding context, and we no longer have to provide the source either. And now if we look at an example in XAML, it's really beautiful. We just set the binding context in our code behind on the content page. And then we start using the binding extension to transport data from the model into the UI and back. By doing this, we have achieved our first main goal. We have successfully decoupled our code behind from the UI. Let's go ahead and try to apply what we have learned about data binding. We'll do a little group exercise together. I'll just walk you through the code. For further details, please consult our lab instructions. Here I am in Visual Studio on Windows, and I am running the starter application of the Part01 resources folder. This application shows you a list of flags that you can scroll through. So here we, for instance, see the flag of Nepal. We see when the current design was adopted, whether it has a shield or not, and we see some facts about it. I can navigate through the available flags by clicking the buttons down here. I'm running this here as the UWP version. You can really run any version that you like, whether it's UWP, Android, or iOS does not matter. We want to talk about data binding here, so the actual UI is not really relevant. Let's inspect the app a bit. It all starts with our app.xaml file. In there, we create a new navigation page, and the initial page that is shown is called the main page. Let's go to that. Our main page is XAML based. You can see in here how it has got a scroll view, a stack layout, and we have our UI elements in here. We have the image, the country picker, we have a label for when the current design was adopted, a date picker, we have a switch in here, we have the description, which is another label, and a link with more information. In the code behind of this file, we find all of the logic. There's particularly one method that is interesting, which is called initialize data. We see it here. This method is called whenever we switch from one country to another. You can see how here we have an event handler called onPrevious, and further down there's another one which is called onNext. This changes the currently selected flag index and then calls initialize data. Initialize data is wiring up event handlers in order to react to changes in the UI. Like here, we have one for the date picker. It also moves data from our model into the UI. Here you can see how it's using the current flag's date adopted property and moves information over to the date property of the picker. Speaking of current flag, this is our public property on the page, which is using a repository that can be found in a separate library. Here it is, flag repository. Flag repository and the current flag property, they return a flag object, which you also find in here. Our flag object has got a country, an image URL, and various other properties that are interesting to be shown in the UI. We want to change this in order to use data binding. So let's think about the three ingredients. We need a source, a path, and a target. Our source should be represented by the binding context, because all the properties that we use, they are part of our flag object. So there's no need to repeat the source over and over again. So let's just set the binding context. I'll stop debugging. And in here, we set the binding context on our page, and we point it to the current flag. This is where all data should be pulled from. In case you wonder why are we setting the binding context after assigning the item source here of our picker, well, the reason is if you do it the other way around, it would reset the current selection in that picker. We want to avoid that. Now we are ready to create our data bindings. We want to start with the selected item of the country picker. So let me show you that. We will get rid of these two lines here and instead create a binding. Our binding will belong to the country UI element. So we call it setBinding method. First parameter is, well, where do we want our data to go to? What is the target property within our picker? This would be the picker.selectedItem property. Here we have it. Second parameter is the binding itself. So we create our binding object. And if we look through the constructors here, we find that there's one which takes the path of the public property inside our source as a parameter. So we can just specify in here, country. As long as you're creating data bindings in code, you can also use an alternative approach. Instead of using a hard-coded string, you can make use of the name of operator, which was introduced with C#6. So instead of having the string country, you could say flag.country and wrap that into a name of call. This makes sure that in case you refactor your application and you rename a property, it will also be changed in here. Now let's quickly verify that this is working. I'll run the app again. Here it is, and we want to switch to the next country. We can clearly see that as I change the current selected country, everything gets updated, including our country selector here. This is the one that we have just changed to use data binding. By the way, you might have spotted this additional icon down here. This is a way to see what is currently in your model. So this allows you to verify that data is really flowing from the model into the UI and back. If I check here, it shows a pop-up that tells me that I'm currently looking at Canada here, the date when the design was adopted, whether it has a shield or not, that's the true here, which is the switch setting here, and where the facts are coming from. And to prove that this is working, if I change here and say this is no longer Canada, this is now Chile, I again inspect my model, and I can see how data has been transported back from our UI into the model. And this is done because we created this binding here in code. Let's now go back here, and instead of doing the bindings in code, we just want to do them in XAML. So I comment this one out here. And the others that we want to focus on are the adopted switch or the adopted date. We already have tackled the country. We want to data bind the shield and the description text. Let's go over to our XAML file. We start with the country picker. Remember, we removed the code in our code behind and now use data binding in here. And we use exactly the same property. It's the selected item property. But now we say that's supposed to be a data binding. And what we're data binding to is the country property of our flag object. Up next, we have the date picker here. Our date picker has got a date attribute. And once again, we use a binding. Now we might have to look up what the name of the property is. Remember, you can easily do that. Just go to the flag object. And we find here datetime, date adopted. I'll just copy that. Up next, we have our switch. There we have the isToggled attribute. Create a binding. And if I remember correctly, this is called hasShield. We can verify. Oh, it's called includes shield. So let's fix that. As you can see, as long as I'm working here in XAML, I cannot use anything like the name of operator. It's really important that you don't change your properties without updating your XAML later. If you do that, and what you use here in XAML and what you have in your model is not in sync, just no data will be shown. It's not that your app will crash or you will get an exception or anything. It's just going to result in an empty entry field, for instance. So that's why it's also important to always know about the three things about binding: source, path, and target. Because these are the three things that you always have to verify in case something goes wrong. Now here for our description, that is a label which has got a text attribute. That would be our description. Again, verify over here, description. With that in place, I'm going to rebuild. And we verify that our data is still appearing as expected. I switch to different countries, and everything seems to update. Let's just try to switch this here, and we go from has a shield to does not have a shield, and verify that indeed in here it now says false. Our model has been updated by the data binding. If I go back here into the code behind file, you might wonder, hey, why have we skipped our image here? What about this one? Well, we cannot data bind this yet. The problem here is that what the flag image, or what this image is expecting as a source, must be of a specific type. And this type does not match what we have in here in our flag object. We will learn how to convert this string-based image URL into an image source that can be consumed by the image. That's the second part of our course here, how to deal with incompatible data types. With that, we get back to the slides here. So far, all the examples that we had, they involved a model object that was part of our code behind. But remember, our source object, that can be anything in data binding. So why not make our source object another view element? Here's an example how this works. There's an extension which is the x::reference extension. By using that and by a name that is assigned to another UI element, you can access this other element. And if you have another element, well, then you can use it as a source. In this example here, we have a label and we try to set the label's rotation attribute. And we want to make this rotation dependent on the value of a slider, which means our source object, that's the slider, we can reference it using x::reference slider, where slider is the name. And we specify the path. Our slider has got a value property. That means path would be equal to value. And as a result, as you drag the slider, the rotation angle of your label will be updated in real time. And you don't have to write a single line of code to achieve that. Another topic that we should discuss is how does data actually flow? If you think back to the application or the exercise that we just did, I showed you that, well, I changed something in my code behind, I updated the currently selected flag, and the UI would reflect that. I also changed something in the UI, and by pressing this little magnification glass icon, I could verify that data went back and changing this shield switch, for example, back to our model. This is typically what we want to happen, and it's good that this is the default behavior. It tells us that data is always flowing from the source to the target, but there are situations where it's also automatically going back from the target to the source. We can influence that. We can use this default behavior, or we can just explicitly set a different mode. The two important binding modes that are exposed by Xamarin.Forms are one-way or two-way. Here we see how we can set them. On the left-hand side, in code. On the right-hand side, directly in XAML. The good news is that most of the UI controls, they have a sensible default mode. If a UI control allows user interaction, you can actually be pretty sure that it will support two-way bindings. That means user changes something in the UI and data will automatically go back into your model. However, be aware that other platforms that support XAML, they might have different default modes. As we are talking about binding modes, let's assume the following. What if our application has got a separate thread that is running in the background? And this thread, it just talks to maybe a web service, and it's supposed to update our local data whenever something was changed on the server. That would mean that while our UI is already on screen, properties in our model could possibly change. And we kind of expect our UI to update magically. Well, there is no such thing as magic. That means in order to get this to work, we need to add some code that will inform the UI of the update of a property. This has been formalized via the identifies interface, also referred to as INPC. It's a pretty straightforward interface. It only has one single event in there, which is called property changed, and the type is property changed event handler. It is up to us to manually implement this identifies interface on our source object in case we want this additional feature that would allow us to change a property and have the UI automatically pick that change up. Here's how that would look like. Instead of having automatic properties in your model, you would have to add a backing field The getter just returns whatever is currently stored in the backing field. The setter, however, it first compares the current value to the new value. If they are different, it updates the backing field, and it then invokes the event handler. And as an argument to the event handler, it passes the name of the property that has just been changed. In our case here, that would be the nodes property. The binding engine in Xamarin.Forms, it inspects your source object. And it's okay as long as it's any object. However, it also tries to detect if your source object is implementing iNotify property changed. If that's the case, it will subscribe itself to the property change notification. And whenever that property change notification is raised, the binding object will react to it. It will then have a look at the parameters, at the event arguments. From there, it will read the name of the property that has just changed. And if the name of that property matches the name that is assigned to the binding, it will go ahead and retrieve the updated value from the source and update the UI. The nice thing about this feature is that you're allowed to change these properties on a thread that is not the UI thread. The binding engine will make sure that the update to the UI will happen on the UI thread. It will automatically marshal back. We have prepared an exercise for you. This is an individual exercise. Please switch over to the lab materials and focus on exercise number 2. When you're done with the exercise, come back to this video and we will review the code. Here we are in the completed version of exercise number 2 of our data binding course. I'm looking at our flag model here. That flag model is now implementing iNotify property changed. That's what you were supposed to add as part of the exercise. Please notice how we have added a lot of backing fields here. One for date adopted, for country, for our include shield boolean, and so on. The actual implementation of the interface is in here. We added a public event property changed event handler called property changed. The binding engine will subscribe to this property changed event handler. All of our properties have been updated to retrieve data from our backing fields and to write updated values into the backing fields. We start by looking at the date adopted property. The getter just returns the current value of the backing field. And in the setter, we first compare if the new value is different from the previous one. If that's the case, we update the old value with the new one. And then we raise our event. Typically, this is done by using some sort of helper method. This helper method is not part of the interface, but you will find it very often. It's just convenient. This raise property changed method in here, if I quickly jump to it, it invokes the event. And as a parameter to the event, it passes the name of the property that has just been updated. If you wonder now, how would it possibly know the name of this property if we don't pass it? It's using the call a member name attribute feature of C#. This allows you, or this allows the runtime, to inject the name of the calling property or method and pass it as a parameter name, which means our parameter called property name will automatically point to the public property where we are calling this method from. If I go back up to our date adopted, you see that we don't provide any parameter. That means the runtime will use the name of our date adopted property, and that will result in the string date adopted. If we try and run this application, we see that we can change our model and the UI will update immediately. Here's the app in action. The instructions of the exercise told you to please add something that would change the properties of your model behind the scenes. And just as an example, we added that here to our icon that allows us inspecting the model. Whenever we click that, it will increase the year of the adoption by 1. We see currently it's 63, and our UI reflects that. If I click again, the model is updated to 64, and our UI updates immediately. That's iNotify property changed in action. To recap what you have learned so far, let's do a little flash quiz. I'll read out the question and then give you about 10 seconds to provide the answer. Here's the first question. With data bindings, how is the source data supplied? Is it A, by setting the data context property, B, by using the binding source property, or is it maybe C, by using the binding context property, or is it D, none of the above? We have two valid answers here. We can either set the binding source property explicitly, or we can set the bindable object's binding context. Both work. What is even better, if you have set a binding context maybe at page level, you can still specify a source property for an individual binding. This will always override what is specified through the binding context. Question number 2. When using bindings, what about our source? Can that be any object? A, yes, or B, no? That can really be any object. And by that we mean it doesn't have to implement any specific interfaces. It doesn't have to derive from any specific subclasses. Of course, if you want these features, like iNotifyPropertyChanged, then you will have to implement this interface. Also, there are some limitations. For instance, your object, it must be accessible and it must contain public properties. Number 3. What about the target? Can that be any object? A, yes, B, no. And the answer here is B, no. The target, that must be a bindable object exposing bindable properties. Number 4. Model objects should perform the following steps when a property setter is called. Please pick the best answer. Is it A, we should first change the property, then raise the property changed event? Or is it B, check if the property is different? If yes, change the property, then raise the property changed event? Or is it maybe C, first check if the property is different, raise the event, and then change the property afterwards? Or is it maybe D, that all of the above are incorrect? The correct answer is that we would first check if the property is different, then change the property, and then raise the event. What about A, if you would just change the property and then raise the event? Well, the result would be the same. It's just that you would raise way too many property changed events, even if the value hasn't changed at all. The other answers are wrong. If you first raise the event and then change the value, the binding engine would read the old value. This event that we're dealing with here is not like an asynchronous operation. It is something that happens immediately. You change the value, raise the event, that very moment the binding engine will re-evaluate the property. This is not queued or anything. So it is important to do this in the correct order. Now we're going back to our very first exercise that we did as a group exercise. Remember that there was one type in there, one UI element, which we did not data bind? Well, that was our image. And the reason why it did not apply data binding was that the data types are not quite compatible. What we have in our flag object is a string. What we need in our data binding, that would be an image source. The binding engine in Xamarin.Forms, it supports various conversions. Let's start with a simple example. Here in this example, we have got a double value called bill amount in our model. And on the UI side, we have a label. The text property of the label is string-based. Still, we don't have to worry about any actual conversion. We can just data bind our double bill amount to this text attribute. Just by saying binding bill amount, this would output the double value and assign it to the label. However, we could influence how the resulting string would be formatted, because otherwise it would just use the default format. If we want a specific format, we can use the string format attribute. This works exactly like the C# string.format method. So if you have ever used that, you're familiar with how string format works in the binding engine. The string that you provide here to string format must contain one placeholder. And in there, all the formatting options that you know from string.format are available. While this is working for simple cases, it has got limitations. Let's assume the following situation. What if you have a UI where you would like to users to enter a password? And depending on the password strength, you want to output in a label whether the password is invalid, medium, good, or excellent. And to really visualize how good or bad the password is, you want to use colors. So if the password is invalid, you want to show this in red. If it's an excellent password, you would like to show this in green. If we think about our code for a moment, we would very likely have some sort of enumeration. That would contain the values invalid, good, medium, excellent, and whatever other values you would like. You can directly data bind this enumeration to the text attribute of a label. The default conversion will take care that it's running toString on the source object, and it would successfully display invalid, excellent, or good, or medium. However, this password strength enumeration that we have here is not a color. So if we want to emphasize our output here and say, well, I would like to use this, I would like to say that invalid is red, excellent is green, and you try to data bind the password strength property that you likely have to the text color attribute, Xamarin.Forms would not know what to do with that, because excellent is not a color. Luckily, Xamarin.Forms supports value converters. The idea of a value converter is that you can enter one type and get another one back. It is formalized via the iValueConverter interface, which has got two methods, convert and convert back. We'll have a closer look at this in a bit. The idea here is that you are writing these converters. You will add something to your code implementing iValueConverter, and in there do the conversion, maybe from a password strength into a color. Here's an example. We have created a password strength converter. By convention, these converters always have the suffix converter. It implements iValueConverter and has got the methods convert and convert back. If we look at the convert method, the first parameter that we get here is an object called value. This is what Xamarin.Forms asks you to convert. Since this can be any type, it is represented as an object. In our case, we know that we would like to use this converter as part of a password strength conversion. So we would cast this value into a password strength. We then inspect the password strength and decide if it's invalid, we return red. If it's excellent, we return green. If it's medium, we might return orange. We can get additional help here from the iValueConverter to tell us what is it that Xamarin.Forms is expecting. That's specified via the target type parameter. If we look at that, it would tell us that I would like to get a Xamarin.Forms.color object back here. There's additional parameters that you can use optionally. There's a parameter that is called parameter, which is, well, anything that you might need during conversion. You could pass that in to your converter. And you also have info about the current culture. Something interesting. The convert back method does not necessarily have to be implemented. In fact, in the case of our password strength converter, it just would not make any sense. Let's think about that for a second. Converting back would mean you have a color and you turn that into a password strength. While this might work in our situation for red and green, what if somebody calls that method and says, here I have purple, what's the password strength? So you see, this doesn't necessarily make sense. In these situations, it's good practice to throw an exception in there with an additional message, maybe telling somebody who's using your converter that that's not the intended use. To set up a converter, we would assign it to the converter attribute of our binding. Again, we can do this in code or in XAML. There is also a converter parameter property in there which you can use to pass in additional information to the converter. We have just seen this on the previous slide. Whenever the binding is re-evaluating the source object, it will just run it through the converter. And whatever the result is, that will be assigned to the target. In case you have a two-way binding, it will run the convert back method if a value is read from the target and assigned to the source. Remember when I said that your application is very likely not to crash if something is wrong with your data bindings? Often it will just not display anything. And one way to debug that is to create yourself some sort of debug converter or dummy converter as it's shown here. Let's assume you are moving data from a person object, first name, into a UI's entry field, and it just does not show up there. If you want to analyze what's going on, you could just plug in a converter. You do this temporarily. This dummy converter does nothing but return the value that's coming in. You can then put a breakpoint in there. And then this tells you different things. If the breakpoint is not hit at all, it means that you very likely have just used the wrong property name. If the breakpoint is hit, you can inspect the value. Maybe the value is empty for some reason. That could tell you that your iNotify property change is implemented incorrectly. You could also put additional logging in here if you don't want to use breakpoints. We have reached our last exercise. And in this list exercise, which is again an individual one, you will get a chance to data bind the missing UI elements. Specifically, that's our image. This exercise will push it even a bit further, because if you go back to the code, you'll find that there's still our item source of the picker, which is not data bound. We want to change that too. Again, please come back to the video if you have completed the exercise. Here we're back in Visual Studio. We're running the completed exercise and our app hasn't really changed. I mean, it's still working, but our code has changed. So I want to focus on that instead. We start by looking at our initialize data method, which we already know from the previous exercise. This is what contained all of the manual setup. We have removed all of this because we are now using bindings for everything. We start by inspecting our main page.xaml. In there, let's focus on the image. See how the source of the image is now also using a binding. And it's pointing to the image URL property of our flag object. I quickly switch back there. Here it is. Image URL is a string. Now, unfortunately, our images are stored inside an assembly. This assembly is here. It's called flag data. It has got an images subfolder, and that's where we find all of the flag images. If I right-click them and go to the properties, we'll find that they are stored as an embedded resource. Xamarin.Forms cannot automatically convert from the string, which is our image URL, into this embedded resource. That's why we have this additional converter. We find this converter in our resource dictionary on the page. We call it embedded image converter and give it a key so we can easily access it. The actual code for that converter is in the converter subfolder as part of our project. We implement iValueConverter and have the convert method and convert back. Convert back is easy because we simply throw a not supported exception here saying that this converter is not meant for two-way bindings. The reason is easy. It doesn't make sense since our image, it only supports one-way bindings anyway. The user cannot change it. In case somebody is using our converter incorrectly, we want to throw this exception to make them aware of this fact. The convert method, it inspects the incoming value. That would be our string. If that string is not null, we use the image sources from resource method to convert the image URL into an actual image source. And that's what we return here. If we go back into our XAML file, we spot another thing. All of the bindings now seem to be prefixed. Where we had country before, it now says current flag.country. Where we had date adopted before, it now says current flag.date adopted. And likewise for our image URL, it's now current flag.image URL. Let's have a look at why this is. we go to our main page, .xaml.cs file, and we see how our binding context is no longer just the current flag, as it was in the previous exercise. It is now an anonymous object. This anonymous object contains two things. One of them is the current flag. The other one is the list of all countries that are available for the app. Because the countries property and the current flag property, they are part of different objects, we have to unify this into one object because we can only set one source. We can only set one binding context. So why not use an anonymous object here? The binding engine is working with reflection. This doesn't have to be strongly typed. And because now we have this binding context, which contains sub-objects, we have to prefix everything with the property that we actually want to use. So it's either current flags or it's countries. We have done this because we want to also data bind the item source of the picker. If I go back here, we'll find that in here, our picker's item source is now using a binding, and it's pointing to countries, which is exactly the property of this anonymous object that we have just created. That brings us back to the slides, and we have one last flash quiz here. Again, I'll read out the question, and then you have about 10 seconds to answer it. Number 1. The convert method of iValue converter is called when going from where to where? A, from the source to the target, or B, from the target to the source? That would be A, when going from the source to the target. And remember, our source can be anything. The source can be a model object, can also be a UI element. Whenever it's going from the source to the target, it will route the call through the converter. Number 2. If we want to pass a binding specific parameter to a value converter, how would we set that? Is it A, the parameter property of the converter? Or B, the conversion parameter property? Is it C, the converter parameter property? Or D, is it called binding parameter? And that's a bit tricky because we haven't explicitly used that in our exercise, but it's really the converter parameter property. Answer C would be correct. Number 3. Binding.string format. Can that be used to convert an integer type to a double type? A, yes, or B, no? And the answer here is no, B, that's not possible. String format never does any type conversions. It only affects how the resulting value will be output. In order to do a conversion, you will have to implement your own converter. With that, we have reached the end of the course. Thanks for watching this course. I hope you learned a lot and can now go ahead and create great Xamarin.Forms applications using data bindings.